Alright, exponential graphs are of the form y equals a to the x. Okay, and we're going to do the same things we did for all those other graphing equations here. So you can reflect them, you can translate them and all that sort of stuff. So you need to work out your base shape, and there are two base shapes. Alright, so you've got your base shape of going through 1, okay, or you can have a base shape of coming down, going through 1. So there's your two basic ones. This is if a is greater than 1. Okay. And this is if a is between 0 and 1. Not inclusive. Alright. So if a, your base here, is 0.5, it's going to be a decreasing exponential function. If it's 1.5, it's going to be an increasing exponential function. Alright, makes sense? So these are two base things. Okay, so if a is between 0 and 1, it's a decreasing exponential. If a is greater than 1, it's an increasing exponential. So that's your base shape. Okay, so you can do your reflections again. Alright, depending on where your negative is, alright, is going to depend on the reflection you do. So if we're doing a reflection, right, if we use our base graph of that, so it's an increasing exponential function, alright, and I want to reflect it this way. What's that going to be? Okay, it's reflected around the y-axis, so it's flipped that way. Yeah. So what is my equation going to be, do you think? Okay, so that is your green one. The negative is on the x. Remember, if you're flipping it around the y-axis, your negative is on your x. Just like when we were talking about your cubics and your quadratics and stuff like that when they were in turning point form, if your x was negative within your brackets, you'd flip it around the y-axis.
What if it was 0.5 and the negative again? Would you flip it?
It'd end up like the black one. So it flips around the y-axis. Alright, but if I wanted it to flip this way, so that's negative 1, what equation is that one going to be?
Minus a to x.
Yes, negative a to the x. So the a is the negative 1, alright, not the x. So same process as all the reflection stuff we've done before, alright, exactly the same process, just with a different graph. So if we continue about translations, alright, so if you've got translations, again, we're talking about our standard graph, so an increasing exponential graph. Now, if I move it that way, alright, so let's say I've moved it this way too. What's my equation going to be?
Would be the power of x plus 2.
Alright, remember it goes the opposite direction to what you think. So if you're moving it towards the positive, it's a negative, and it's within that bracket just like before. Alright, it's within that bracket. If I moved it back the other way, so if I'd moved it back here, alright, that would be a plus 2. Alright, so that one's green. So if I wanted to move it up or down though, what's it going to be? So again, let's draw a graph, a standard exponential. If I moved it, so the original is 1, alright, crosses the y-axis of 1, this is crossing at, let's say it's 4. Okay, what's my equation going to be? Okay, so it's external to your x. It's outside of it, just like before. All right, it's shifted up 3. Make sense? All right, it's exactly the same as all the other ones you've done before. Yes? No? Maybe? Yep. So the last one we really need to talk about is dilations. Okay, so your standard graph, okay, going through one, there's a couple of ways you can dilate. You can dilate from the x and you can dilate from the y. And this is where it gets a little bit sketchy. Okay, so remember in the past for dilations we had an a out the front, or a number out the front multiplying. So if our standard equation is a to the x, and we put a number out the front, let's say it's 4, okay? We are dilating from the x-axis, and what are we going to do? All right, what's that going to actually do to our graph? If we're multiplying every point by 4, it's going to squish it, isn't it? Okay, so it's going to start, and it's going to go up a lot higher, and it probably should have actually gone through 4, sorry. Right? So what if I had it as 1/2? All right, it's going to stretch it lower, isn't it? It's going to go through a half and come out a little bit lower. Okay? That one is the normal dilations that you guys know about, yeah? So that's the easy one. There is one more kind of dilation that we haven't really talked about with the others so much, and that's from the y-axis. Okay, so if we have a look at our standard graph again, going through one, y equals a to the x, right? If I have it a to the 2x, what's it going to do? Yeah, it kind of twists it a little bit. It's still going to go through 1. It sort of comes down lower and up quicker. Right? Whereas if I had it as a half, what's that going to do? Sort of stretches it the other way. All right, it's still going to come down here, but it's going to come out there a bit different. All right, so the difference between your dilations about the x-axis, all right, is that you can shift it up and down. All right, you do shift away from your standard point. All right, with this one, you still always go through the same point. Quick question, why? Because if x is 0, it's always going to be 1, isn't it? Because anything to the power of 0 is 1. So it's always going to go through 1 here. But if x is 0 here, then a to the x is 1, and then you multiply it by 4, so you can shift it up and shift it down. All right, so keep that in mind. All right, so if we're going to do an example, right, this is an equation. It asks you to find the equation of the asymptote. It's asking you to tell me where the asymptote is. Okay, the asymptote is the lowest point that you can get at. Okay, generally speaking. So back here, your asymptote was always 0. Okay, this one I can tell you is shifted where? Up 5. Okay, so if we draw our base graph going through 1, and then we're going to shift it up 5, so we're going to go through 6. Okay, we're going to keep the same basic shape. Then we are reflecting it because we're negative. And which way are we reflecting it there? Across the y-axis. So I've got to come back through like that. Okay. And then what am I doing here? Grab another different colour. I'm stretching along the y-axis. Am I? Right, I'm moving it to the left 2, to the negative 2. So I'm going to come. Alright, I'm going to come back this way too. And I go through whatever I go through there. Okay.
Is there 10 in the structure?
The 10 is just a number. It doesn't. That will change. That won't change anything to our base shape. Okay. The 10 is just a number. All right. It changes the values, but to our basic shape, if we're sketching it, it doesn't change. So let's talk about our asymptote at each point. Asymptote for our base shape, all right, is y equals 0. Is our asymptote. Okay. It's never actually going to touch 0. As soon as I shift it up 5, that's what we did first, isn't it? No? Yeah, red, up 5. Alright. What does my asymptote become? Yeah, so y equals 5. If I reflect it, does it change my asymptote? No. If I move it to the left, does it change my asymptote? You're just shifting the whole graph. Okay, so it doesn't change it. So what should the equation by asymptote be? Y equals 5. Alright?